C2 plus C1. So the answer for the equivalent capacitor is the product of the two capacitors divided by the sum of the two capacitors.
This is very important video which can be which gone through. You can easily find out the capacitance in a series circuit and in a parallel circuit with the derivation of the voltage and the charges according to that series and parallel capacitor. Now just gone through the next question number 3b. Define the RMS value and derive the equation for the same. The importance of the RMS value, 7 marks. First of all, the RMS means that root mean square value. The short form of that one is RMS value. As we all know that the DC current which is fixed throughout the circuit operation, the value of the DC cannot be changed throughout the operation. But that statement is not same for the AC current. As we all know that AC is an instantaneous current. The value of the AC is changed by instant to instant, time to time. Starting with that, the current of the AC, as you see that it's starting with the zero level, gradually increasing, reaches to one peak point or the maximum height. Again it starts decreasing slowly, and again it reaches to the zero level and start increasing, but with the opposite side. Again reaches to its peak level, starts decreasing, and again reaches to the zero. So ultimately what happens, the positive alternation and we get the negative alternation, and with that alternation, positive and negative, you just find the different time instant. The value of signal is, for example, 15 to minus 15 voltage. So here the instant, many instant T1, T2, T3, T5, T10, whatever, etc. So this is very complex thing, and this is very difficult to find out the value at the different instant in a AC signal. But this one is very simple with using this is for AC signal, this is for DC. For the value of DC, first of all, for example, a 15 voltage. So this is the straight line. So at the direct any instant you can just find out the value of DC, but that is not happen in the AC circuit. So to find out the effective value in a AC signal or in a AC circuit, there is a one term which required to easily identify, which is reliable to give the explanation of the AC signal, and that is a value which is known as a RMS value, root mean square value. So again I'm just talking that the common platform is required for the AC signal, which easily or reliably give the value of that any instant. You can just find out the value of the signal. So the RMS value can be determined by using the common platform. Now the definition of the RMS value. RMS value is equal to the DC value which, when the flowing through the given circuit for given time, produce the same heat which produced by the AC when flowing through the same circuit for the same time. So as we all know that the DC circuit can be easily stored, and you can easily identify the value of the DC circuit. So ultimately we just perform that the heat produced by the DC circuit is equal to the heat produced by the AC circuit. So ultimately we just find out the heat produced by the DC circuit and apply that equation for the AC circuit. So we can just easily find out the any time of instant the parameter of the AC signal. So the value of the IRMS is IRMS equals to Im by root 2. This is the equation of the root mean square current at any time of instant in the AC circuit. Now starting with the derivation of RMS value. As we all know that the instantaneous current that is known as a instantaneous current I, and the value of that instantaneous current I is Im sine theta. This is sine wave, so the equation is sine theta, and this is if this is for the current, then that one is the maximum value of the current, so it is I, and this is instantaneous. At any time of interval, the value of the current is change different instant, so that is known as a II. So ultimately I equals to Im sine theta. The square of the instant value of the current is the mean of the square value of the instantaneous value of the current over the half cycle. So we just find out the value of the current for taking just the half cycle, and shows the derivation of the RMS value. See that I square equals to the region of convergence is the 0 to pi, the half 0 to 180 degree. The full cycle is 0 to 360 degree, but we are just talking about the half cycle, so 0 to pi, the I square d theta upon pi minus 0, that area of the convergence. So I square is 1 by pi, because pi is a constant, so you kept the outside the integration, 1 by pi integration of 0 to pi I square d theta. Now I is our instantaneous current, so put the value of I, that is Im sine theta, and the rest to square. So ultimately the third step become I square equals to 1 by pi integration of 0 to pi Im sine theta raised to whole square d theta. Now again Im is a constant value of that particular current, so you can also keep the value of Im outside the equation. So fourth step is I square equals to Im square upon pi integration of 0 to pi sine square theta d theta. Now just using the mathematical equation for the sine square theta, that is 1 minus cos 2 theta. So substitute the value of that 1 minus cos 2 theta into equation of 4, and that become that I square equals to Im square by pi integration of 0 to pi. So instead of sine square theta, you can write that 1 minus cos 2 theta by 2 d theta. Now just taking the 2 is again the constant, so just taking the 2 again the kept from the outside the equation, so we get that I square equals to Im square by 2 pi integration of 0 to pi 1 minus cos 2 theta d theta. Now just solving that equation for the integration, as we all know that the 1 is a constant, so integration for 1 is the theta, and the integration for cos 2 theta is sin 2 theta by 2. So taking that one, we get the next equation, that is I square equals to Im square by 2 pi, 1 is theta, integration of 1 is theta, minus cos 2 theta integration is sin 2 theta by 2. Now put the value of the limit 0, minimum limit is a 0 and the maximum limit for the equation is pi. So put the value of pi and 0, we get that I square equals to Im square by 2 pi, instead of theta you can write that pi, and sine, value of sine 0 is also 0, and value of sine 2 pi at any time of interval or instant, the value of sine 2 pi is also 0. So theta minus 0, pi minus 0. So ultimately we get that pi are cancel out, so I square equals to Im square by 2, and you are getting and if you want to talk about only the I, then you get that I equals to Im by root 2. You are just getting the value, that is I square equals to Im square by 2. Now finally if you are removing the square from the both the side, then you get that they are cancel out, so Im by root 2, because you can write like that Im square equals to Im into Im upon 2 is also, you can write like that root 2 into root 2. So square are cancel out, so ultimately we get that I equals to Im by root 2, or you can see that this is the IRMS value so this equation shows that the amount of heat can be generated for the DC current passing through the circuit is same for the heat generated for the AC circuit. The RS value can be calculated as follow, that IRMS equals to the under root mean of the square of the instantaneous value, as we already find that the IRMS equals to under root Im square by 2, or IRMS equals to Im by root 2. So the value of root 2 is 0.707. So you can see that IRMS equals to 0.707 Im. This is the final value of the root mean square value current.
Three concepts of average: the mean, the median, and the mode. These are a good start to averaging, but are not the end of the story. There are more types of average measure depending on the situation you find yourself in. Root mean square is another type of average that gives you an average value of the magnitudes of a variable. It is particularly important in the study of AC currents, as the mean would give us a value for current around 0, which suggests that negative current has no use. This isn't the case. Negative and positive currents are equally as useful, so we need to find a way to make those negative parts of our sine wave positive and then average across them. How do you make a negative positive, yet keep its identity? The answer is simple. You square it. 8 squared and minus 8 squared are the same. If we are only interested in the magnitude of a number, then squaring it allows us to have just that. Only positive values all the time. Doing this gives us lots of peaks on a graph that are far bigger than the peaks or troughs were before. How do we bring these peaks back down to size? The answer is simple. You square root it. But what if not all of these peaks are the same size? How do you account for peak variation? You account for it in the same way you would normally. You take a mean value. So, let's go through the steps. We want only positive values for our current, so we square everything. This makes it too big. We want to account for any variation in the magnitudes of these peaks, so we take an arithmetic mean. We want to bring these results back down to the size they were originally, so we square root them. This is how we do a root mean square. However, this can take a while to do for all the data you get.
This one can be easily shows that if you are taking the value, any current, instantaneous current, the value is increase, peak level decrease, flowing like that. So this is the maximum amplitude of the current, and here where the dotted line is your RMS value. So ultimately this one is 0.707 your Im. So you have to just find out that point, and just taking any one of the example, any one of the portion of that value, you can conclude any all the parameters for that particular equation. So for us it's very important to have the value of IRMS. So according to the value of Im, for the instantaneous current, you can find out the value of IRMS. Thank you.